Chapter 12, Statistics. We're moving to section 12.2, Measures of Central Tendency. Objectives. We're going to determine the following: the mean, the median, the mode for a data set. They have repeated the fourth one. Mean. The mean is the sum of the data items divided by the number of items. Remember from an earlier chapter that this symbol means the sum, so it's the sum of x, where x represents the data items. N represents the number of items. Example 1, we're going to calculate a mean. Are inventors born or made? It would be nice to think we could all be great inventors, but history says otherwise. Based on a sample of adults in 10 selected countries shows wide agreement that inventiveness is a quality that can be learned. Find the mean percentage of adults in the 10 countries who agree that inventiveness can be learned. And this graph is a little hard to read. Sorry about that. We want to calculate the mean, so we find the mean by adding the percents for the countries and dividing by the number of countries. So although it was hard to read, we can see that the numerator is going to be the percents for the countries, which we have indicated here on this slide. There are 10 countries. The sum for the top is 799 divided by 10, which is 79.9. That would be the mean. Next, calculating the mean for a frequency distribution. When many data values occur more than once, and a frequency distribution is used to organize the data, we can use this formula to calculate the mean. In this formula, X represents each data value, F represents the frequency of the data value, and the summation XF represents the sum of the products obtained by multiplying each data value by its distribution. N represents the total frequency of the distribution. So we follow this with an example. We want to calculate the mean for a frequency distribution. The table on this slide shows the students' responses to the question, how stressed have you felt in the last 2.5 weeks, on a scale of 0 to 10, with 0 being not stressed at all and 10 being as stressed as you possibly could be. Use the frequency distribution to find the mean of the stress level ratings. So the solution, first we want to find XF, which we obtain by multiplying each data value X by its frequency. So looking in the third column, we see that the stress rating is 0, the frequency is 2, so 0 times 2 is 0. For the second row, 1 times 1 is 1. Next, 2 times 3 is 6, and so on. Then we're going to use this formula to find the mean. So this tells us that we are going to add those values that we got in the third column, and we're going to divide by n. So we see that the total is going to be 975. That's the total for the third column. N is equal to 151, which is approximately 6.46. Next, median. Median is the data item in the middle of each set of ranked or ordered data. Now notice that it says ranked or ordered data, so you may be given data but it's not in the right order, so we have to do that first. So to find the median of a group of data, we arrange the data items in order from smallest to largest. If the number of data items is odd, the median is going to be the data item in the middle of the list. If the number of data items is even, the median is going to be the mean of the two middle data items. So in this example, we're finding the median. We want to find the median for each of the following groups of data: 84, 90, 98, 95, 88. These items are not in order from smallest to largest, so that's going to be our first thing that we do. So we arrange them 84, 88, 90, 95, 98. Because there's 5 of these data items, that number is odd. So the median is the middle number, which is 90. For this part, we have another set of data items. We have to arrange them in order from smallest to largest, which we have done below. The number of data items in this list is 10, which is even. So the median is the mean of the 2 middle numbers. The 2 middle numbers in this are 28 and 34. So we add those together, which is 62. We divide by 2, and that gives us 31. So 31 is the median, but it isn't in the list of the data items. Example 4. We want to find the median using the position formula. Listed below are the number of letters in the 9 longest words in the English language. We want to find the median number of letters for the 9 longest words. The data items are arranged from smallest to largest. Notice we have 25, 25, 27, 27, 28, 29, 29, 34, and 45. The median is in the n+2 position. The number of items is 9. 9 plus 1 is our numerator. That's 10. Divided by 2 would be 5. So that tells us that the median is in the 5th position. 1, 2, 3, 4, 5. That would be 28. So here the median is 28. Example 5. Find the median for a frequency distribution. Going back to the stress level rating. We have 151 data items in this table, so N is 151. They are listed from 0 to 10 for the stress ratings. The median is the value in the 151 plus 1 divided by 2 position. So 151 plus 1 is 152. We're looking at the frequencies. Divided by 2 is the 76th position. Counting down the frequency column in the distribution, we've identified the 76th data item. And this is shown on this slide. So we're counting. We have 1, 2 in the first row, 3, 4, 5, 6, and continue counting. We get to 76, so we've reached the 76th data item. This is 7, so the median stress level rating is 7. That is our X, that's in the first column. Example 6, comparing the median and the mean. 5 employees in a manufacturing plant earn salaries of $19,700, $20,400, $21,500, $22,600, and $23,000 annually. The section manager has an annual salary of $95,000. We want to find the median annual salary for the 6 people. So first we're going to arrange them in order. They were pretty much listed in order in this example, but sometimes you have to rearrange them. There's an even number of data items, 6. So the median is the average of the 2 middle items, which be the 21,500 and the 22,600. Adding those together and dividing by 2, we get 22,050. Notice again that the median is not always one of the numbers that data items that you're given. Now we want to find the mean annual salary for the 6 people. To find the mean, we add them all together and divide by 6. That gives us 33,700. So you can see that the median which is when 2050, and the mean are very different. And that is because of the extreme difference in the salary of the manager, the 95,000, much higher than the other salaries. Finally, we're going to look at mode. Mode is a data value that occurs most often in a data set. If more than one data value has the highest frequency, then each of these data values is a mode. If no data items are repeated, then the data set has no mode. Example 7, we want to find the mode for the following groups of data. Okay, the number that occurs most often is 7, so the mode is 7. Mid-range. The mid-range is found by adding the lowest and the highest data values, we don't care about the other ones, and dividing the sum by 2. So this is only looking at the lowest and the highest values. Again, remember to list all of your values in order from smallest to largest. Example A, find the mid-range. Newsweek magazine examined factors that affect women's lives, including justice, health, education, economics, and politics. Using these 5 factors, the magazine graded each of 165 countries on a scale from 0 to 100. The 12 best places to be a woman and the 12 worst places to be a woman are shown on the next slide. We want to find the mid-range among the 12 best countries to be a woman. So here's the table. Remember, for the mid-range, we take the lowest score plus the highest score. We're looking at the best places, which would be this left side of this table. So that would be the 87.2, which is the lowest, plus 100, which is the highest, divided by 2, and that gives us 93.6. That is the mid-range. And that would be very close to Denmark, which is 95.3. And that concludes this lesson.